Hey, what's going on, everybody? It's Derek, and we are back here in week two where we're going to be looking at compute, which is very important. You're going to want to be pretty familiar with the compute tier, but the compute is the tier of service that is used to process workloads, handle app logic, evaluate rules, react to conditions. It's the brains and the processing power. So you need it for pretty much everything. So again, we're going to want to know compute here pretty well. It's tied closely to CPUs and RAM. Uh, the, the main services that you're going to be using in the compute tier uh, are really EC2 and Lambda. And the key difference between, when you would use EC2 versus Lambda is EC2 is generally for longer term use cases. So, maybe you need like a web server with like a public IP address. You could put that on an EC2 instance. But say if you needed to just like run some functions, that's where you would use Lambda. And Lambda is basically just like available compute power that AWS has out there that you can use. And again, it's just for like very short term tasks, um, or functions rather, or what they're actually called in Lambda. But just, things you need done, but you don't need to like provision a whole server for is basically what you use Lambda for. There's a few other applicable services kind of under this compute umbrella, and they'll all get their own spotlight. We'll get to them because you need to at least know from a high level what they are. But you need to be, pretty familiar with EC2 and Lambda. So we're going to spend quite a bit of time on those two. So EC2 is the flagship AWS compute service that allows you to launch virtual machines, which AWS calls instances. I know like Azure calls them VMs, so it's kind of confusing, but at AWS they're instances. But basically, like what a VM in general is it's an emulation of a physical computer using software. So it's like having a laptop without having a physical laptop. And you can have multiple VMs running on the same physical server, multiple instances on the same physical server, which allow you to share costs of that server with other customers, right? So that's that economy of scale where AWS has the physical hardware over here, and then everybody just kind of like plugs in by provisioning their own instances, via software, and then everybody pitches in to pay for that server. You can configure your EC2 instances to meet pretty much any business requirement. So it's a very flexible service. And EC2 can be broken down into the following components. So you've got Amazon Machine Images, AMIs, instance types, instance purchasing options, tenancy, user data, storage options, and security. Let's look at each of those, starting with AMIs, because they're all going to be pretty important components. But AMIs are essentially templates of pre-configured instances that let you quickly launch a customized instance. So instead of like setting up all of your instances, in each one manually, you got to go through and specify like what you want, what kind of OS, whatever. You can just build out a template and apply that template to multiple instances that you launch. So it really helps you kind of automate things. Uh, but AMI consists of an OS and application configurations and any other custom configuration that you want, and a block device mapping that specifies EBS volumes to attach. So if you need, to get an EBS volume on there for more storage, you'll be all set. And you can also purchase AMIs from the AWS Marketplace. So maybe you have like a specific use case. You could just go get that AMI from the marketplace, and then just pay for the underlying resources that you use with that AMI. So what it would kind of look like is you have your AMI here, right? This big orange blob, and you've got three different instance types down here. You got some T2, A1, C5. But instead of like again setting up this T2 and saying the OS and everything on it, and then doing A1, same thing, whatever, you could just tell each of these three to use this same template, and now you're good to go. So it saves you a lot of time, and again, you can automate a lot of stuff using this kind of this concept. So EC2 instance types, we were just looking at those, right? So like T2, A1, Z5. There's 5 types of instance families that you can use depending on your use case. So you have general purpose, which is just a balance of compute, memory, and networking resources. It's kind of the default, the go-to for most use cases. Compute optimized, which is ideal when you need pretty high processing power. You've got memory optimized, which is used for workloads that are processing large data sets in memory. Accelerated optimized, so it's primarily used for machine learning. And then storage optimized when you need high read and write access to large data sets on local storage. Okay. When you're like provisioning an instance, this just gives you an idea of what it would look like. As you can see, there's 366 different options available in this particular region that I was selecting in here, but this only shows 6, but you can see they've all kind of got their own attributes. So again, depending on your business use case, you can really find the instance that you need. So EC2 pricing models. This is definitely one of the big pros to cloud computing and AWS is the amount of options you have to pay for stuff. So you've got on demand, which is the default for instances, and that just means that you just pay as you go, and you only pay for what you're actually using, right? So it's not like traditionally you purchase your own server and you have to deal with all that stuff. You just pay for what you use, and then once you stop using it, you don't have to pay for anything anymore. And it works based on hourly rates. So like we saw back here for this on-demand Linux pricing, it was pricing it out per hour. Reserved instances, on the other hand, are helpful if you're going to need these instances in the future. It's not really a question of if you'll need them or you're experimenting. You've made the decision you're going to use them. It's best for apps like that or that have a steady, predictable usage. You can commit to 1 or 3 years of usage. So if you commit to a longer term, like 3 years, then you'll have more savings. Your instances can be standard or convertible, both of which offer substantial savings when compared to on demand. And you can modify or you can exchange. You can modify the standard instances, or you can exchange the convertible instances for different instance attributes. So that's just what that means. But you can pay up front. You can pay partial upfront or no upfront, which that just means the amount of money you pay AWS upfront right away when you start using everything. If you pay more upfront, you're going to have more savings and a lower monthly payment, but of course it requires more money upfront. And you can share reserved instances between accounts. And this is actually kind of nice. If they're not being used, you can actually sell back the standard instances on the AWS Marketplace. At the time of this, you couldn't sell back convertible, but just you could sell back standard reserved on the marketplace, which is huge. Again, you could definitely save money that way. And then you have spot instances, which is going to be where you will save the most money with EC2 potentially. All the way up to 90% sometimes. But the problem is, it's not necessarily recommended for workloads that cannot be interrupted. So you wouldn't want to use spot instances for business critical applications that can't tolerate downtime. You'd maybe want to use them for maybe batch processing jobs that can tolerate interruptions. But yeah, spot instances will save you up to 90% when compared to on demand. And they're designed for workloads that have flexible start and end times because at any time, AWS can take that back if it's needed by, on-demand customers that are willing to pay more than the spot price. You've got scheduled instances, which basically you're going to be paying for instances that'll run on a daily, weekly, or monthly schedule. So, for example, if you're going to need 5 hours of running instances per week, you could just schedule that at a certain 5 hours during the week. They are similar to reserved, but you pay for them whether you use them or not over a 1-year term. So it's not like you can sell them back to the marketplace. You can still pay with all partial or no upfront. And then just note that AWS currently doesn't have reserved capacity for scheduled. and it's just recommending that they're using on-demand capacity reservations instead. But sometimes scheduled instances shows up on the exam, but just so you're aware. So on-demand capacity reservations are where you reserve instances in a specific availability zone for any duration for a specific instance type. Excuse me, there's no time commitment required, and then you can create and cancel as needed, so it's kind of flexible there. There's no billing discounts, unfortunately, and on-demand instance limits per region apply. All right, so tenancy. So EC2 tenancy is what allows for cost savings between customers, right? Because again, like I mentioned earlier, AWS has all the hardware, and then your EC2 instance that you provision is called a tenant, right? So it's tenancy. So there's three types of tenancy. There's shared, which is the default, where multiple AWS accounts from all sorts of customers are using the same physical hardware. You have dedicated instances, which are instances that run on a single tenant hardware, not necessarily an entire host. And you have dedicated host, which is when an instance runs on its own physical server that you can control and configure. So dedicated instance and host are kind of confusing. Um, just know that with a dedicated host, you have the most control. So if there's like licensing concerns, then you generally want to defer to dedicated hosts. But dedicated instance is kind of just like a segment of hardware on a server that's dedicated to you, as opposed to a dedicated host where it's like its own physical server. So that's kind of difference there, but even for me, it's a little confusing. So EC2 User Data allows you to enter commands that will run when an instance first boots up. So for example, you can install a web server on an instance or download, OS updates or, basically whatever you want a instance to do when it boots up. That's what you can put into user data here. So that's pretty helpful. Again, especially for automation. So storage options. So for EC2 instances, they are designed to work very, very closely with EBS, so Elastic Block Store. So it's just block storage. So EBS, and they're called volumes. So the persistent storage is an EBS volume because EBS volumes can be separated from an instance. They're logically attached to instances via AWS network. So again, AWS takes care of like associating it. All you have to do is say what you want it, attached to. You can actually detach these volumes though from the instance it's using and retain that data, right? So it's almost kind of like taking a USB stick, and then you can encrypt your snapshots, and you can encrypt and take backup snapshots. Of course, encryption is best practice for security, so you can encrypt your snapshots and your volumes. But you also, for instances, have ephemeral storage, which is on the instance itself. It's physically attached to the whatever hardware your instance is running on. But the problem is that when your instance is stopped or terminated, all the data on your disk is lost. Um, you can reboot your instance without losing your data, though. And I believe you can hibernate it as well, which is kind of a relatively recent feature. But if it's stopped or terminated, then that data is gone. So it's not recommended for critical data storage. So, if you need, again, persistent storage, because you maybe want to switch your instances every now and then for whatever reason, use EBS, or if you just, again, need your data to stay intact, use EBS. But if it's for like local temporary storage, you can use ephemeral, which should be actually a little faster than EBS as well because it's actually on the instance itself. All right. So EC2 Security can be broken down into three areas, and I think this might be a little easier to look at. But you've got your security group configuration. You've got your key pairs, so your public and private key. And then you've got regular patching of your operating system, your OS. So if we look here, so this is our subnet that's holding our instances. And security groups act at the instance level, which is why you want to be aware of what kind of traffic your security group is allowing in, once it gets into your subnet, past your NACL over here. So, your security group, again, controls traffic and security at the instance level. We'll get into security groups more later on. And then your security groups can, of course, go across different subnets, or you can specify different security groups based on what you got going on. So it looks like this one has a database, so it'll potentially have different rules than this one up here that just has 2 instances. So your key pairs are going to be what help, get you access. Say you needed to RDP or SSH into your instance for maintenance or access or whatever. Your key pairs are going to be what basically authenticates you to allow you to connect to your instance and do what you need to do. And then, of course, OS patching is, just recommended to keep things up to date, fix bugs, whatever. But to elaborate a little more on like the keys, because it's kind of confusing, right? Because there's access keys, there's encryption keys, there's house keys. But basically, what'll happen is when you create an instance, you'll generate a private key and a public key. And what's going to happen is the AWS key pair with the public key is going to be generated. So basically, it uses the public key to associate with this instance. And then you keep your private key, right? It's private. And then it will match up with the public key that's mapped to your instance. And then that's how it'll authenticate you. All right. So auto-scaling groups and load balancers. These 2 services are huge. You're definitely going to want to be aware of these. Or maybe not services, I should say concepts. But they allow you to achieve high elasticity and scalability for your compute workloads. So auto-scaling groups can automatically add or remove instances to meet your performance requirements. So this is how, like, say you have a spike in traffic and you need more compute power, you can have auto-scaling automatically add compute power, and then once that traffic goes down, you don't want to pay for all of that. So auto-scaling can take it back down. So again, you're not paying for what you don't need. And then load balancers distribute traffic between instances to achieve best possible latency for your end users or your application or whatever. There's 3 types of elastic load balancers. There's an app load balancer, which is used for distributing traffic from the web to targets in your network. And targets could be like EC2 instances or containers, some other stuff as well. And it's generally handles HTTP, HTTPS traffic. The network load balancer is used to handle millions of requests per second and is designed for like very low latency, very high performance. It uses TCP traffic. So by the way, if you ever see like question on the test, talk about which load balancer is designed for extremely high performance that can handle millions of requests. You're thinking network. Gateway load balancer, which is used to distribute traffic across a third-party virtual appliances. App load balancer and network load balancer are the 2 you're going to want to know more about, but it's good to be familiar with the gateway as well. So auto-scaling, again, uses customized and defined metrics that allow you to scale out or scale in, which basically means increase or decrease the size of your EC2 fleet automatically. And some of the main benefits of this are, of course, automation. So if something happens at 2 in the morning, you're not required to fix it. It'll heal itself. You can have high customer satisfaction because, again, if you have network traffic, it can automatically detect that and scale up, which will give them lower latency and a better experience. And then you've got cost reduction because, again, you can automatically remove resources you don't need anymore, so you're just not paying for unused resources. All right. Some of the main, we already went there. So the auto-scaling group visualized, if we look down here. So how auto-scaling works is you have a minimum, a desired, and a maximum capacity or size. And you specify each of those values, and auto scaling will kind of take care of the rest. So for example, say you needed at least one instance to keep, your application running. Okay, well, you can tell auto scaling, hey, do not go below one instance. That's my minimum I need, okay? I would like to have two, though. That's my desired capacity. So, if it's needed and available, then let's really try to keep it at two. And then say, once we get more traffic, oh, hey, now we're going to potentially need two more, but only add those as needed by, predetermined conditions. So this is really nice because, again, you can automate the kind of latency availability of your infrastructure mostly automatically. All right. So let's actually, you know what? It's been about 20 minutes. Let's go ahead and take a 5-minute break, and then we'll pick it up with some auto scaling components. All right. Go ahead and take a 5-minute break here.
Hey, Murillo, you blessed.
All right, welcome back. All right, uh, some auto scaling components of EC2 that you'll want to at least be familiar with are launch configuration or templates. Templates are more commonly used and a little more user friendly. You'll have AMIs. You'll have the instance type. You'll want to consider, if or you have even the need to use spot instances or the capability rather. Again, are you going to want to use a public IP? You'll want to have some user data potentially. You'll want to think about your storage volume configuration, and then again, your security group configuration. Auto-scaling groups, again, tells AWS the minimum, desired, and max amount of EC2 instances that you want, and it'll specify where to scale resources. So, for example, if you want to, put them in another availability zone, you can specify that. So, auto-scaling policies there's four types that you can use. You can use a manual one, which is where you adjust your fleet size manually. It's really only useful if like maybe there's a rare event it's coming or whatever, but you generally want to avoid manual things or answers on the test even that reference manual procedures. Dynamic, which is kind of the main way to use auto scaling. You're going to use either step scaling or target tracking. So step scaling is where you add or remove a specified number of instances based on a tracked metric like CPU usage, tracked via CloudWatch, which we'll talk more about in the future. And then you have target tracking, which is similar to step scaling, except you just define a threshold, and AWS will automatically add or remove instances to meet your demand. Okay. Then you have scheduled scaling policies, which will add or remove instances based on time parameters, and then predictive scaling policies, which predict when your traffic is up or down, that will allow you to add or remove resources. But again, dynamic is primarily the main way to utilize auto scaling. So load balancers. When this is combined with auto scaling, you can create very robust, reliable, and fault tolerant architectures. Because, for example, here you have three different EC2 instances, and you've got a load balancer that's balancing traffic out to each of these. So, the main function of the load balancer is to manage and control the flow of inbound requests destined to a group of targets. And targets could be EC2 instances, like in the picture here. It could be Lambda functions, containers, or even a range of IP addresses. But again, the nice thing is you can control where your traffic goes and how much traffic goes there. Pretty cool there. And again, that provides your architecture with a lot of resilience because you can not overload maybe this kind of top instance with too much traffic. It'll automatically balance out for you. And then if one of these instances goes down, you can set health checks, which we'll talk more about in the future, to basically prevent any more traffic from going here and giving your end users a bad experience. Okay. So load balancers have a few components. You've got listeners, which define how your inbound connections are routed to your target groups based on ports and protocols, which are set as conditions. You've got your target groups, which are groups of resources that your Elastic Load Balancer routes traffic to. And your load balancer can use multiple target groups, each having their own listener configuration. And then you have rules, which are associated to each listener that you configure. And they utilize conditions and actions, like if-then statements is a good kind of way to think about it, to, send traffic to a certain place. It's important to note too that ELBs can have one or more listeners, and then each listener can have one or more rules, and then each rule can have one or more conditions, and all conditions in a rule lead to a single action, right? So that's kind of the thing. You just want just individual actions, right? Which is maybe routing to a certain place or whatever. So if we look at a kind of a illustration down here, you've got your load balancer, which is going to be catching your traffic, and then it's going to take a look at those listeners. Okay, I'm listening for, say, HTTP traffic, and maybe this one's HTTPS traffic. Okay, so if I get HTTP traffic, I have two sets of rules here, and then if I get HTTPS traffic, I just have this one rule. Okay, now we take a look at this rule, and if it meets this condition, then we're going to do this action. If it meets this condition, we're going to do this one action. If it meets this condition, we're going to do this one action. So you can see kind of how you can kind of get intricate and complex and pretty granular with like rules in your configurations and your routing of your load balancers. So it's a pretty flexible, pretty cool service. So I mentioned health checks. Your load balancer is going to target resources with a specified protocol to make sure it gets an expected response. And if it doesn't if no, that should say response. Let me just change that real quick. I'm getting a little sneak preview here, aren't you? So if no response is received from that ping or request, rather, your load balancer is going to mark the target as unhealthy, and then it's going to stop sending traffic there. All right. So yeah, this again just gives your end users a better experience, so they don't get routed to a maybe an EC2 instance, for example, that's not working right. You can have internal or external load balancers. An external, which is going to be an internet-facing one, is going to have a public DNS name that can be resolved to its IP address, and it's also going to have an internal IP address. But an internal one, of course, is not going to have a public IP address, right? It's internal to your account. So it can only serve requests that originate from within your VPC. So that's kind of the difference there. And then you've got ELB nodes. So each availability zone you want to use your load balancer in needs a node in it. These are automatically created. But to do cross-zone load balancing, each availability zone is going to need a node. So application load balancer. So again, this is used to support HTTP and HTTPS traffic at the application layer, which is layer 7. And it can also support SMTP and NFS protocols. It has cross-zone load balancing always enabled, and this is kind of what it looks like in the console when you go to set one up. You've got network load balancers, which are used for TCP UDP network traffic, which is at layer 4. And you have, or it is rather designed to handle millions of requests per second with very low latency. So again, if you see those keywords on a test in a load balancer, you're thinking network. And then gateway load balancers. So you use these to balance inbound and outbound traffic between virtual appliances, like instances running on third-party network, or rather running third-party network appliance software on them, and your VPC. So these are more of a specialized use case. Just know that these are kind of used for third-party software. But again, the primary ones you're going to want to know and be familiar with are app and network load balancer. All right. So ECS, Elastic Container Service, and containers. We'll just touch on these real quick because it's important to know what they're for. You'll probably get asked about them, but you don't necessarily need to know like super in depth kind of how they work and whatever. But ECS supports Docker-enabled applications packaged as containers across a cluster of EC2 instances. And just as a refresher, a container holds everything an application needs to run, except for an OS, kind of decouples it, which makes containers kind of appealing. And it's done primarily by using AWS Fargate to manage and provision instances and clusters for containers. But containers can be monitored with CloudWatch to see events like scaling or any other kind of container related events if you're trying to manage and track your resources, specifically your containers in this case. And then if an ECS cluster is basically just a collection of EC2 instances that act similar to an EC2 instance, except that they're going to aggregate resources like CPU and memory, but you can only scale these within a single region, so they can't, kind of cross over regions when you're scaling. So Elastic Container Registry provides your ECR provides a secure location to store and manage Docker images. ECR components include the registry itself, which is what hosts and stores the images, authorization tokens, which grant Docker client access to the registry. You've got your repository, which are objects within the registry where you can group images into different categories. You've got your repository policy, which allows you to control access and actions in the repo, in the repository rather, and then your image, which are objects you build containers with. So ECR, that's kind of what it is, what it does. Just good to be familiar with, but again, you don't have to be super in depth with the knowledge there. Elastic Kubernetes Service. So Kubernetes is a container orchestration tool to automate, deploy, scale, and operate containerized apps. It's probably the most utilized container orchestration tool there is, at least at this point in time. But EKS integrates with Kubernetes to abstract the control plane and leave you with only managing the worker nodes. So basically, the control plane is what schedules your containers onto nodes, and it tracks the state of all your Kubernetes objects. But the worker nodes that you manage are what actually make up the Kubernetes clusters, which, again, EC2 instances, and they use specific AMIs. So it's kind of nice that it takes some work away from you. So AWS Elastic Beanstalk is an AWS managed service that takes your code and provisions the required resources in AWS to make your web application operational. So it's going to use EC2 auto scaling and load balancing. The service itself is free, but it's going to provision resources for your application. Those are not free. So just fun fact there. But some of the core components of Beanstalk are going to be your application version, which references a section of just deployable code. Your environment, that's the application version that has currently been deployed. You've got environment configurations, which are a collection of parameters and settings that determine resources deployed and their behavior. You've got the environment tier, which is the web server or worker tier based on if the app handles HTTP requests. The configuration template, which is the baseline for making new environment configurations. And then the application, which is just the collection of different elements like environments, environment configurations, application versions. Most of those components you probably don't need to know. But it is important to know that Elastic Beanstalk is a service that helps basically build a web application for you. So that's kind of what that's for. AWS Batch is used to manage and run batch computing workloads within AWS. And batch computing just generally requires large amounts of compute power across a cluster of resources to complete a series of tasks. And just like I mentioned earlier, it works well with spot instances. But batch components, the main kind of unit is a job. It's a unit of work that's run by batch. You have job definitions, which specify how a job runs, and with what configuration, like how many vCPUs, what kind of mount points it uses, etc. Job queues are where jobs sit until they actually run. Job scheduler is what it handles when jobs run and from which compute environment, if you have different computing environments. And then compute environment is the environment that has compute resources needed to carry out a job. It's generally ECS clusters, and it can be either managed or unmanaged. Okay. AWS Outposts, you probably won't use these unless you work for a company that uses AWS, but it's used to support a hybrid cloud and on-prem environment when a company requirement needs like some applications or services to run on-prem. But it's basically like physical hardware that's brought to your on-premise data center that allows you to use native AWS services. And you have two options for Outpost. You could use VMware on AWS, which lets you run your native VM infrastructure. And then you have a native AWS variant, which lets you use the same API and management tools just like you would in AWS. You order racks for the console, and then they're patched by AWS when it's needed. Again, you probably won't use these personally, but it's good to know that it's kind of contributes to that hybrid environment, and it's a physical piece of hardware that AWS gets to you. So AWS Lambda, this is the primary serverless service from AWS. So when you hear serverless computing, it's generally Lambda. It lets you run compute workloads without actually having to like set up and specify a server for it. It's comprised of functions, which it's similar in that how EC2 is instances, Lambda is functions. Uh, you need to write your functions, which functions support pretty much all programming languages, so Python, C, C++, whatever, everything you would expect. Lambda supports it, and then you can either invoke them manually, which again probably not recommended most of the time, or automatically based off of events and triggers. You only pay for the compute that you use when your functions are running, and you can monitor functions and code being run with CloudWatch. You keep seeing CloudWatch. We're going to spend some time on it in a few weeks. Um, so that's a lot of stuff. It's mostly EC2 to be honest when it comes to compute, but there are a few other important services that you'll kind of need to know. So let's just go through like a quick kind of summary of this section. You can reference this maybe like when the test is getting closer. So you have Amazon machine images, which are AMIs that are templates based on existing instances that you can use to quickly launch new instances. Instance types. Different types are defined by their values and properties like memory, storage, and network performance. Some instances don't support ephemeral storage. I've seen that as a question before, so it's kind of important little fact to know there. You've got 5 different instance types. You've got general purpose, which is used for various broad use cases. Compute optimized, which is used for compute heavy workloads like batch processing or scientific workloads. You've got memory optimized, which is used for processing data sets in memory, like big data analytics, for example. You've got accelerated computing, which is used for very high performance compute workloads like machine learning. You've got storage optimized, which is used for workloads that need high IOPS performance. So EC2 purchase options, you can have on demand, which instances can be launched and terminated at any time. You just pay as you go for what you use. It's used for irregular or interruptible workloads or maybe some testing. Spot instance, by far largest cost saving, but it's really only recommended for workloads that can afford to be interrupted. Reserved instances, so you're going to be purchasing instances for 1 or 3 years. You're going to pay by using all, partial, or no upfront. And if you do more upfront, it's going to be a lower monthly payment. Of course, if you do all upfront, it's no monthly payment. Scheduled instances is you pay to reserve instances on a recurring basis, and it's going to be best for scheduled workloads. And then capacity reservation are when you reserve capacity for EC2 instances with specific attributes like instance type, platform, etc. EC2 tenancy, you can have 3 types. You can have shared, which is the default, where you share underlying hardware with other EC2 customers. You've got dedicated instances, which are where you run instances on single tenant hardware. You've got dedicated hosts. And that's where your instance runs on a physical server dedicated to you, not necessarily like a segment of hardware on a server, but the server that you can configure at will. So it's much more configurable and under your control. EC2 Security, so you have key pairs that encrypt your credentials to the instance. The public key encrypts the data, and then the private key decrypts kind of the authentication data. You can use the same key pair on multiple instances too. Uh, EC2 autoscaling, you can use this to automatically increase or decrease your EC2 instances to meet demands of your application. Scaling up means increasing the size of the existing instance, and scaling out means adding more separate instances. Scaling out is generally recommended, by the way. Launch, you can launch templates, launch templates define the AMI instance type and other properties of a new instance when it is launched. And then autoscaling groups let you define a minimum, desired, and maximum capacity of instances to use. So elastic load balancing is where you control and route the flow of incoming traffic. It uses listeners, target groups, and rules. It can be an application load balancer, which is for HTTP, HTTPS traffic. It can be a network load balancer, which is for TCP, UDP traffic. And it can be a gateway load balancer, which is for kind of like third-party software or other applications that you need to connect to. And then targets can be maybe an EC2 instance fleet, Lambda function, or containers. And we have Lambda now, which is again the main serverless compute service. It uses functions, and then you only pay for the compute power used when your functions are run or are running rather. And then functions are triggered by supported event sources like S3, for example. All right, so we made it through compute. It's definitely a long section. I think this was like 30 slides, something like that. But definitely check out the labs. Refer back to the summary if anything is unfamiliar. And we will see you next week for storage, where we'll talk about our first kind of way to store data. All right. So good luck with the labs, and we'll see you next time.